Hi, lab people. Well, it's about time we get going with our, Astronomy Laboratory 117. Uh, I've been thinking a lot about how we can do this. It's going to take some time. The first lab we're going to work together on, and it's going to probably be a couple of weeks, if not 3, to get this done. We'll just take whatever time it is necessary. It is lab number 7, Kepler's laws. One of the biggest, problems and really kind of confronting the human race was to figure out how things moved through the heavens. At the beginning of, gosh, thousands of years ago, the Greeks thought the Earth was the center of the universe and everything moved around us, including the planets, the sun, the moon. And so one of the great searches was to figure out how do things really work? Is the Earth the center of the universe, or is it the sun? What is it? And so, as it turns out, of course, we know that we do orbit the sun. We do know that the sun is not the center of the universe, but that took a lot of effort to figure that stuff out. And so, in the 1500s, there was a Danish astronomer. He was really a courtesan, a member of the king's court of Denmark, very rich and very interested in understanding how do planets move. His name again was Tycho Brahe. And with Tycho Brahe, he took a long time to actually look in the sky and very, very precisely measured where the planets were and measured against when he actually did the recording, so he recorded position in the sky and time. And using that data that he recorded for years, he wanted to figure out how do planets move. Of course, that's a big, gigantic math problem, and he was rich, so what do you do when you're rich and you need something done? You hire someone. And there's a huge story, it should be something you should read about sometime, is the story of Tycho Brahe and the story of Johannes Kepler. And so it took Kepler roughly 20 years to solve the problem of how planets move in the sky and, of course, moving around the sun. So what is this lab about? What it is we're going to use actual data. And that data is shown in the book right here. And that's on page 86. And what you'll see is there's an X and Y position for a satellite that's orbiting the moon. And there's also a time when they made that recording. And so we are going to use that actual data, and from plotting that data, which is kind of hard to see, but this is the actual plotting of that data. It took me some time to plot it correctly. But the point here is using that data, we're going to plot this using the graph paper in the appendices of your textbook, and very carefully utilizing this graph, we're going to verify that Kepler's laws of planetary motion are correct. Now, understand something. These laws were revolutionary, and it requires some understanding of some geometry of things called ellipses, squashed circles. And we will get there as we go along as I do these lecturettes to make certain that we understand what the lectures mean, and then how do we use this graph to determine if those lectures are right or wrong. Excuse me, those laws are right or wrong. Now, what we find here, just so you can see, is as I point this out, I wish it was easier to see. I'm trying to figure out a better way, and so I will certainly explore with this to see if I can find a better way to show you this. But right here, I don't know if you can see it, is a circle, and that's the actual moon. And what I did is I made the X and Y axis, so there's the X axis, that dark line, and there's the Y axis, that dark line, right in the center. And what I did, if you count, there's 1, 2, 3, 4, 5 of those little grids that make up a radius of the moon. And so there's 0, 1, and then I count out 5, 1, 2, 3, 4, 5, 2, and so forth. The other way, from 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, with 5 grids in between. Now notice something, that I didn't put the XY axis right in the center of the page. It can't, because if you look at this orbit, it kind of tips over a little bit. Do you see? And what's cool is I've shown you where to put this. I put the origin, just so you know it, going counting out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 grids over, 11 grids from that side over, and 1, 2, 3, 4, 5, 6, 7, 8, 9 grids up from the bottom. And so that's where you would draw then your x-axis and y-axis following along the lines of the grid, passing through that origin. And then using, something like a compass or something that the best you can, you try to make a circle centered on that origin to represent the moon. Then what you do is you carefully, step by step, walking through the data, what you see, if I can find it again. So the first one, if I look on table 1, is x is minus 3.62. So I would go, let's see, 1, 2, 3. And then what I would try to do is, again, try to find point to see if that's minus 3, minus 3.2, minus 3.4, minus 3.6, slightly beyond that, and I go up 1.04. So there's 1.04. So I slightly go up, and that's where I would place my point. It's very hard to do. You take your time. You notice how that's nice and uniform. Just take your time, and we need to graph this. So this is the first challenge. I'm not going to give you tons of information right now. One is to read the front page. 2 is to answer those 2 questions on the middle of the second page, on page 84. Answer those questions from reading what's on the first page of the lab and what's above those 2 questions. And so basically from that then, we'll be going through the definitions, and all of these will be defined as we go along, and I'll point them out as we work on this. So let's double check. And again, I wish I could, I'll see what I can do to make this a little bit more visible. You draw this using the graph paper. You may need to take 2 pieces of graph paper to make it fit. And you want to make it so that the orbit doesn't go off the page, and it shouldn't if you're careful. As you look at this, if it's squashed in, double check the data points. And let's just keep communicating on what to do. Now, what I'll do next is start stepping carefully through one part after another using this. And between now and next time, I'll see if I can find a better way to make this more visible to you. So let me just repeat. You have an XY coordinate system that's not centered on the page. And what we do is we use 5 of the little grid points to count 1 unit on each axis. So just to be very clear, there's the origin right here. There's the origin, so I count out 1, 2, 3, 4, 5, and that's the edge of the moon. 1, 2, 3, 4, 5, the edge of the moon, minus, and then 1, 2, 3, 4, 5, and I would have a circle centered on the origin, and that's the moon. Then carefully using the data on that first table, very carefully plot out. Now, one last thing about this. So there's 5 little grids for each count of 1 unit for each axis. So I would count 1, 2, 3, 4, 5, and there's 1. And 1, 2, 3, 4, 5 of the grids. There's 2. And so let me be a little bit more precise and a little more careful and say this. Grid 1, 2, 3, 4, 5 for unit 1. And then grid 1, 2, 3, 4, 5 for unit 2 and so forth. And I do this for both positive and negative settings. I hope this is clear. It will take us time to do this. Be patient. Know that I'm not going to ask for perfection. Just try to do the best you can. And I will soon get back with you on where to go from here as we do the geometry of ellipses. And that's what that shape is, a squashed circle. And we'll talk about why that's an important thing that Kepler discovered using Tycho Brahe's data. So I'm going to say it again. Answer those questions on the second page of the lab. Look over the rest of the lab. Get the graph paper from the appendices of in the back of your textbook and start trying to graph this and utilize the information I've given you. One thing that's nice is you can replay this step by step. And in the next day, or probably, in fact, not probably, tomorrow I'll post some more and I'll discuss this again to see if I can help you then step further into discussion of the geometry of ellipses. And that will be all of lecturette 2 for the laboratory. And then lecturette 3 is when we start working with this. And you'll be able to work with the lecturettes, with your book, and with giving me emails. Hope you guys are doing well. Relax. We're going to take it easy. I'm still thinking about how to do the midterm, and I'll get more information with an announcement on the Canvas site. So guys, this is what you should be doing. Go to the Cypress College website, look in the upper left corner for the Canvas button. Click on that. Go in, log into Canvas with your ID and password. Find both the lecture if you're in my lecture class, or find the lab if you're only in my lab class, and start looking at the modules. And in the modules will be all these lecturettes about what to do. We're working again, experiment number 7. Take care, guys. Talk with you very soon. Be patient. I'm certainly going to be with you. Be patient with me as I try to figure out how to do this. I feel like I'm kind of driving a plane while I'm trying to build this plane. So how much fun, huh? Be safe in all the things you do. Have that social distancing. Take care of yourself. Be good to who you're staying with. As an extrovert, I'm having a lot of fun being in my home by myself. So yes, how much fun is that, huh? So let me know how you're doing. Make certain you let me know that you're seeing this. Be involved. If you know of anyone in the lab course that is not connected with us yet, please do that. And remember, there's a Facebook site that you can go, a group, and it's called Professor P-R-O-F, Prof. In fact, let me just write it out here. It's Prof. Astro Mike, Cypress College Astronomy. So please join that group. And I will talk with you guys soon. Take care of yourselves, okay? Bye-bye.